thing we want to talk about is the commutative property for multiplication. What is a commutative property? You switch both numbers around. When commute, if people commute to work, they ride in the same vehicle. And who drives probably changes based off of the day, based off of the week, based off of the month. One week I will drive, the next week Lindsay will drive. I'm nice and let her drive her own car sometimes, but commute. You go together to work. Who drives does not make a difference because you will both end up getting to work together, no matter who drives. So if I ask you to find the product, or back to the commutative property, what is 2 times 3? 6, but 3 times 2 is also 6. So the order in which you multiply them does not make a difference. What other basic arithmetic operation has the commutative property as well? Basic operation of arithmetic. So we're talking about addition, subtraction, multiplication, and division. We have the commutative property for multiplication. What is it? Addition, subtraction, you're telling me another property. You're giving me another property, but what I want is does the commutative property work for addition? Yes or no? Yes, because I know that 2 plus 3 is equal to 5, and I also know that 3 plus 2 is equal to 5. Does it work for subtraction? No. Is 10 minus 2, 8, different than 2 minus 10? Yeah, what is 2 minus 10? Negative 8. That gives you additive inverses. So it does not work for subtraction. It works for multiplication. Does it work for division? What is, Milo, you're correct. You're saying no. 10 divided by 2 is what? 5. But what is 2 divided by 10? 1/5. You get a multiplicative inverse now, which is reciprocals. So the commutative property only works for multiplication or addition. Those are the only two. So what I want you to do right now is I want you to multiply the following statement. Now notice I have it in different orders up here. Does it matter which one you pick? No, you should get the same answer. So I will give you 30 seconds to go ahead and multiply the problem up on the board. 30 seconds to go ahead and multiply the problem up on the board. Sorry, Mom. Now you know how most people It's a football game. I know it's not football. Answer? Volunteer? Negative 144. Wait, what? Wilson, what method did you use? What way did you switch them around? And then you multiplied? So you took negative 48 times positive 3? Yeah. So Wilson grouped the negatives together, which is in one way that I have written up here. He grouped the negatives together, and you can only multiply 2 numbers at a time. And he came up with negative 144. Now, as you go through this, you have to remember what is a negative times a positive, what is a negative times a negative. Did somebody else use a different method? Did you multiply the numbers together in a different order? Straight across? I'll show you this method probably here in just a minute. As you went straight across, if you went straight across, did you choose this first one? The last one. So you went negative 6 times -4, which is what? 24. And you took that times 3, which is 72. And you took that times -2, which is -144. Does anybody know their perfect squares? Because Mr. Levine had you memorize them up to 25. If we look at it, what do you get when you multiply? And this would work for the first one too, because you have the same numbers. What is -6 times -2? 12. What is 3 times -4? -12. Now keep in mind, what are you doing between these right here? Multiplying. So this is not saying addition and subtraction. You are multiplying those two numbers together. What is 12 times 12? 144. So a positive times a negative is a negative, and 12 squared is 144. If you know your squares, grouping them to get numbers that are the same so that you can just square it is easy. You talk about those ways some people can get it quickly. It's because they know 12 times 12 and they can see that. And they don't have to do something like this. 24 times 3, which is 12, 72 times 2, which is 4 and 14. You could have taken this and multiplied and had 24, and then multiply and get a -6, and multiply those together. 24 times 6, and then ended up with -144. But the commutative property, so it does not make a difference the order in which you multiply the numbers in. The last thing we want to talk about is the conversion of areas. I have two congruent rectangles up on the board. Congruent means they have the same size and they have the same shape. And I know they're congruent because I made one and I cloned it. So I know it's exactly the same. If I were to take that triangle and drag it over here, it's going to line up exactly. So the two triangles are congruent to each other. But the difference, what's the measure of one of them? In inches. Over here, I have an equivalent triangle, but I started to put the units in. What did I say? Triangles? Gosh, you mean those are rectangles, guys? Oh my God. And I'm going to post this on YouTube. Oh my goodness. Yeah, I know. I got to make this one private, don't I? Oh my goodness. Two rectangles. Should I back up and start over? The two rectangles are congruent to each other. One of them is in inches, the other one is in feet. 12 inches. You should know by now because your unit conversions, 12 inches is the same thing as 1 foot. I have 36 inches. How am I going to convert that over here? 3 feet. It is the same thing as 3 feet. So if I ask you to find the area, what is the area of the first rectangle? Or how do you find it? I'm going to take 36 times 12. Base times height, length times width, whichever way you prefer to make your statement on the formula. I did that correctly, right? I'm not going to divide it by 2 because that is a rectangle, not a triangle. So the area is 432. What are my units? Square inches. Inches squared, square inches. Okay, but what's my area in feet? 3 square feet, because I want to take 3 base times height, and so I just end up with 3 square feet. Everybody agree with the area of both of those rectangles? All right. If I gave you just the area in feet. So if I told you the area of a rectangle was 3 square feet, and if I ask you to convert that into square inches, unit multipliers, some of you would say, oh, well, I'm going to put feet down here, inches on the top, and there's 12 inches in 1 foot. What's 3 times 12? 36. Is my area of this rectangle 36? No. The reason that if you look at the units you are left with, the units you are left with right now, I have 1 foot left and I have inches here. Because where do we even get square feet from? Where do we get square inches from? Area. I'm taking 36 inches times 12 inches. What is inches times inches? Something times itself is squared. 3 times 3 means 3 squared. 5 times 5 means 25, or 5 squared. Inches times inches means inches squared. Right now, if you look at your inches, if you look at what you're going to convert into, you would say you have 36 foot inches. Does that sound like something we measure or something in? No. So because it is squared, the square feet means feet times feet. And I've only gotten rid of one of them. That's why I have foot inches. So if you are converting units, we didn't just convert 12 inches into 1 foot. We also had to convert 36 inches into 3 feet to find the area of the rectangle. So now I'm going to perform that twice. I have to convert both dimensions. Now the second foot cancels. I have inches times inches, which is square inches. What's 12 times 12? We just talked about that one on the last page. 144. So if I take 144 times 3, I end up with 432 square inches. Is that what we had for the rectangle in terms of inches? Yeah. You have to convert both dimensions. So if I didn't provide you with a picture and I just gave you the units, you have to perform that conversion twice. You have to perform the conversion twice to account for both dimensions in that calculation. I have an example up here. I would like you to work through that for me. I will give you a minute with a partner to go ahead and work through that particular problem. All right, if we look at it, start with your given information, 44 square inches. I want to convert that to square centimeters. So I want my end result. Square centimeters means centimeters times centimeters. Square inches. What does square inches mean? Inches times inches. The only thing squared is your units, not 44. It's not 44 times 44. It's just inches times inches. So I want to get rid of inches, so I put that in the denominator. It's square inches. I need to get rid of square inches, so I got to get rid of inches twice. That's where the 2 unit multipliers comes from. What do I want to convert that into? I want to convert that into square centimeters. So if I perform it twice, the inches cancel once, cancels twice, and what units do I have left in my setup? Centimeters squared, centimeters times centimeters. So I look at that conversion. 1 inch is 2.54 centimeters. 1 inch is 2.54 centimeters. How do I express my answer? Well, in the numerator, I have 44 times 2.54 times 2.54. What are your units? Centimeters squared. I had to kind of scrunch that down towards the bottom. Now, if you wanted to, It's okay if you put 44 times, what's 2.54 times 2.54? I don't expect you to calculate it, but if you take it times itself, it's the same thing as squaring it. You could write your answer in this format as well. I don't care. Either format. The 44 is not squared. And that's what I see happen a lot, is you square the number that you start with as well. Not everything's squared. People are just like, oh, unit conversion. It's squared units, so I'm just going to square all my conversion factors. Maybe the conversion factors, but they accidentally square the original number, and you don't. So be careful of that. 24 years of teaching, I've seen that a lot. Let's look at another example. Use 4 unit multipliers to convert 125 square centimeters to square feet. So start with your given information. 125 square centimeters. How many unit multipliers? 4. 1, 2, 3, 4. Talked to Dustin Rankin this weekend on Friday night. He's 6 months away from becoming a veterinarian. And he said, unit multipliers, let me tell you, railroad tracks have come in handy. Tomorrow, we will come back and revisit this one. We'll do a little bit of review of what we did, and then we will work on the assignment. Dustin Rankin.